Hello, my name is Mark Timmons. I'm a student at Thomas Edison State University, and this is my oral presentation for Nuke 495, Nuclear Energy Engineering Technology Capstone course. As a part of this course, I'm in the team that is addressing the topic of the nuclear renaissance. Is it fact or is it fiction? For this oral presentation, I'll be focusing on a subtopic of comparing and contrasting nuclear power to alternate forms of energy production. These alternate forms of energy production include a look at the fossil fuels of natural gas, coal, and oil, and additionally the renewable resources such as solar, wind, and hydro. First, let's take a look at nuclear power. Nuclear power is one of the safest forms of energy production. Since the 1950s, when the first reactors went critical, there have been over 28,000 reactor years of operation, and during this time period, only 28 deaths have been attributed to the radiation exposure from a nuclear reactor. All 28 of these deaths came from the Chernobyl reactor accident in 1986. When you compare this death toll to the death tolls of other forms of energy production, you can see nuclear ranks extremely well. In addition to the outstanding safety record of nuclear power, the amount of radiation exposure from nuclear power is relatively low. The average person on Earth will receive 300 millirem per year due to naturally occurring background radiation. People living within 50 miles of a nuclear reactor were expected to receive an additional 0.01 millirem per year, a relatively insignificant amount. The average radiation worker at a nuclear power plant will receive an additional 160 millirem per year, or about half the radiation exposure from the annual dose. So the stigma that nuclear reactors emit a large amount of radiation to the general public is false. In addition to this radiation exposure is the argument that nuclear reactors produce lots and lots of radioactive waste. The actual truth is quite contrary. Since 1957, there have been approximately 38,000 tons of high-level nuclear waste, or about enough to cover a football field 5.5 feet tall. That compares to the average 1,000 megawatt coal plant, which produces over 400,000 tons of ash a year, and all this ash just eventually gets buried anyways. The additional benefits of nuclear power include the low fuel costs and a stable market. The fuel costs of a nuclear power plant make up a marginal overall cost in the price of electricity. If the fuel cost for a nuclear power plant were to double, the overall increase in electricity price would be about 9%, as compared to coal, where you would see a 31% increase in electricity price, and natural gas, where you would see a 66% increase in electricity price. Another benefit of nuclear power is the low greenhouse gas emissions. A typical 1,000 megawatt nuclear reactor will have a greenhouse gas footprint over a 40-year period, which includes the construction, operation, and maintenance periods, will produce 83 pounds of CO2 per megawatt hour. This compares to natural gas, which just during operations alone will produce 1,100 pounds of CO2 per megawatt hour. Oil, during just operations as well, will produce 1,700 pounds of CO2 per megawatt hour, and coal is around 2,200 pounds of CO2 per megawatt hour. One of the disadvantages of nuclear power is the high startup cost. This is the largest driver for the cost of a nuclear reactor generated electricity and is the main factor when the price comes down to the consumer. Another disadvantage is radioactive waste disposal. As discussed earlier, the amount of radioactive waste generated by nuclear reactors is relatively low, but time is running out for the storage capacity of commercial facilities to store this radioactive waste. Yucca Mountain has always been mentioned as an alternative, but even if Yucca Mountain were open today, it would be completely filled with the radioactive waste that is currently stored at all commercial plants. Now let's take a look at natural gas. Natural gas is a resource with a large volume and a low cost. This large volume and low cost is attributed to the development of fracking technology in the United States. This fracking technology is the use of using water injected into deep wells at high pressure to break up shale rock and retrieve the natural gas deep in the Earth's crust. This developed technology is expected to increase the supply and demand in the United States by 13% out to the year 2030. Another benefit of natural gas is how low of a greenhouse gas emitting fossil fuel it is. Fossil fuel emissions from natural gas are about half as much as a typical coal plant. However, on the downside, natural gas does emit methane, and methane is 21 times more detrimental to the warming effects on the atmosphere than CO2. The emissions of methane will need to be regulated in the future and will incur additional costs on the natural gas production. Additionally, the practice of fracking releases natural gas into underground water supplies, which can contaminate the drinking supplies of populations around the world. Coal is another fossil fuel form of energy that we'll take a look at today. Coal is very plentiful and cheap and has been used by many countries for many years. This long history of coal use throughout the world has kind of resulted in a reliance on coal for use in energy production. There have been many technological advances throughout the years that reduced the emissions from a coal plant, such as the precipitators that were developed in the 1960s that can collect over 99% of the ash emitted from a coal combustion process. However, this does not prevent the release of greenhouse gases. Greenhouse gases emitted from a typical coal plant are about double the greenhouse gas emissions from a natural gas plant when you look at a per BTU basis. Another downside of coal that many people overlook is the radioactivity that is naturally occurring in coal. Coal has impurities such as uranium, plutonium, and as the coal is burned off, these radioactive elements get concentrated in the ash. And then this ash is just discarded, as mentioned earlier. If this radioactivity were controlled and regulated in the same manner as a nuclear plant, coal would not produce electricity at an efficient enough manner that would be competitive with the other forms of energy production. Additionally, due to all the downsides attributed with coal energy production, it is slowly being replaced by natural gas, as discussed earlier, due to the availability and the low cost of this resource. The final fossil fuel source of energy we're going to take a look at today is from oil. Oil is a vital resource that's been used around the world for many years. As you can see in the graphic, the transportation industry dominates the use of oil. This domination of the transportation industry means that oil can ultimately drive the cost of other forms of energy production, as these other forms of energy production rely heavily on the use of the transportation industry as well as fuel to power industrial processes such as mining for natural resources. Oil is slowly being phased out for use in the electricity generation sector due to the lowering cost of natural gas, and additionally the stricter controls being placed on CO2 emissions. Additionally, a downside of oil is its extremely volatile market. As many of you have witnessed throughout your lives, the cost of oil can increase and decrease based on world events, especially in the United States, where we import a large amount of oil. As domestic supply increases in the United States, the effect that world events will have on the oil price in the United States will be diminished. Another disadvantage of oil are oil spills. Oil spills are extremely hazardous to the environment and not only cause large damage to the environment, but also place a heavy economic burden on the company at fault. The first renewable form of energy we're going to take a look at today is solar power. Solar power is a relatively new technology, and as advances are made in this sector, it is going to lower the overall cost for solar power. Additionally, solar power is a very plentiful resource. In 25,000 square miles of land in the southwest United States, there is more than 4,500 quadrillion British thermal units of solar radiation that hit this area each year. Simply converting 2.5% of that energy would match the nation's total energy consumption in the year of 2006. Concentrated solar power is another advance in the solar energy production field. Concentrated solar power utilizes metallic mirrors to focus sunlight onto a pipe that is filled with a fluid, which heats the pipe much like a huge magnifying glass. The hot fluid will then run through a heat exchanger, which will produce steam and turn a turbine. This steam, however, will not be produced at night due to the fact that solar power is not available to heat the fluid. Some of the heated fluid during the day can transfer its energy to a molten salt mixture, which could provide this heat needed to heat the steam during a time when the sunlight is not available. A disadvantage, however, of solar power is to produce electricity in the southwest United States and distribute that throughout the rest of the United States would be required to restructure the electrical grid. The current AC electrical grid would have to be changed to DC electrical grid to minimize the amount of energy lost over large areas of land, which is going to incur additional cost and additional time. Also, baseload power issues with solar power would have to be addressed. Baseload power is the power that is available 24 hours a day. So as the sun is not out or it is nighttime, an alternate source of energy is required to produce electrical power. The next renewable form of energy we're going to take a look at today is wind. Wind is similar to solar power in many ways. The baseload power requirements of wind and solar are extremely similar since they are both based on a resource that is relatively unpredictable. Wind, however, unlike solar, incurs higher startup costs. This is mostly due to the construction costs of the wind turbines as well as mounting these turbines in the high wind areas. High wind areas are areas where the average annual wind speed is greater than 15.7 miles per hour. In the United States, these areas include Lake Michigan and off the eastern coast of the United States. Mounting the wind turbines in this aqueous environment poses an additional challenge to engineers as well as economic burden on the companies investing in this resource. As mentioned with solar power, the baseload power requirements can be met by similar systems as shown in this picture. The energy from the solar power or the wind turbines can come into a facility where a motor powered by the electricity will power a compressor that'll pump air into a huge underground cavern. As the sunlight goes away for solar power or the wind dies down for wind turbines, this stored energy in this cavern can be utilized by another facility to power a high pressure turbine which will spin a generator and provide electricity during times of low energy demand. The final source of renewable energy we're going to take a look at today is hydro. The benefits of hydropower include low greenhouse gas emissions during operation, a long history of energy production, and long life for hydro facilities. There's really only two sources of hydropower in the world. The two types include run-of-the-river hydropower, where just a part of a river's flow is directed into a facility where it spins an impeller to power a generator to create this electricity. And you have reservoir hydropower, which is the more traditional use of hydro, where you build a dam, it backs up a large body of water into a reservoir, and then you control the release of that reservoir downstream to power an impeller, and this in turn will spin a turbine to produce electricity. The disadvantage of hydropower includes few remaining locations to efficiently utilize this technology and the creation of large bodies of water. The few remaining locations are due to the long history of hydropower being used and additionally the long life of the average hydropower station. The large bodies of water that are created when you utilize reservoir hydropower produce lots of greenhouse gas emissions, including methane. This is due to the biodegradation of animal life, as this body of water displaces large amounts of land. After reviewing the different forms of energy production, that brings us to the topic of today's presentation, the nuclear renaissance. Is it fact or is it fiction? The nuclear renaissance is a fact. It has been happening for a long time and it is happening now. However, progress has been really slow. This slow progress can be attributed to the high capital costs for nuclear reactors, the low cost for natural gas and oil, as well as the negative public opinion on nuclear power. However, as the NRC approves and licenses more reactor designs, the increase in nuclear energy production is bound to increase. As you can see in the graphic, which comes from the Energy Information Association's annual energy outlook for the year 2015, the projected supply of electricity generation by nuclear power goes down from 19% in the year 2013 to 16% in the year 2040. This attributes mostly to plant shutdowns as well as very few new plants coming online in that time frame. However, in that same graph, you can see an increase in natural gas from 27% in the year 2013 to 31% in the year 2040. That is attributed to, as we talked about earlier, the developments of the fracking technology, the low cost of natural gas, and also the technological advancements in that sector. Renewable energy increases from 13% in 2030 to 18% in 2040 due to the advances in solar and wind turbine technology. Coal production in the electricity generation sector, however, goes from 39% in 2013 to 34% in 2040. This is mostly due to the fact that the coal plants are slowly being replaced by natural gas plants, and as CO2 emissions are more and more regulated, coal plants are going to be slowly phased out of the energy production sector. However, this graph does not take into account any future CO2 caps or taxes which could affect the other sources of energy production other than nuclear and renewables. So as these CO2 caps and taxes take effect in the near future, we can expect to see an increase in electricity generation in both the nuclear and renewable sectors. To conclude this presentation, we took a look at the pros and cons of nuclear power, and we also compared and contrasted nuclear power to various forms of fossil fuel-based sources of energy, as well as renewable sources of energy. We also talked about the status of the nuclear renaissance and its slow progress in our current time period. The references used during this presentation were the nrc.gov website search engine, as well as the Adams public documents. Additionally, worldnuclear.org was referenced, and the energyinformationassociation.gov was utilized as well. For a complete list of references, please consult the bibliography of the final presentation. Thank you.